THHN and TFFN are both types of building wire used in electrical applications, but they have distinct differences in their properties and applications. Let's examine these differences in detail. Firstly, the conductor material differs. THHN wire can be made of either copper or aluminum, while TFFN wire is made of copper only. Secondly, insulation type also differs. THHN uses PVC, which stands for polyvinyl chloride insulation. TFFN uses FEP, which stands for fluorinated ethylene propylene insulation. Thirdly, temperature ratings are different. THHN has a temperature rating of 90 degrees Celsius dry and 75 degrees Celsius wet. TFFN has a higher temperature rating of 150 degrees Celsius both dry and wet. Fourthly, voltage ratings are different. THHN is rated for 600 volts, while TFFN is rated for 300 volts. Fifthly, stranded versus solid construction differs. THHN is available in both stranded and solid conductors, while TFFN is available in solid conductors only. Regarding the availability in 16 or 18 gauge stranded, THHN is indeed available in these smaller gauges with stranded conductors. Now, let's talk about the suitability of TFFN as a replacement for THHN. Due to its low voltage rating of 300 volts, TFFN is not a suitable replacement for THHN in all categories. TFFN can only be used as a replacement for THHN in applications where the voltage does not exceed 300 volts. THHN wire is commonly used in industrial and panel applications because of its versatility and high temperature rating. TFFN wire is more expensive than THHN and is typically used in high temperature and or corrosive environments. While the National Electrical Code, or NEC, is not directly applicable to industrial applications, its guidelines can provide guidance on safe wiring practices. Always consult with a qualified electrician or an electrical engineer when selecting and using wire types to ensure code compliance and proper performance. Considering these differences is important for choosing the right wire for a specific electrical installation. The conductor material influences conductivity and cost. Copper is a better conductor than aluminum, but is also more expensive. The type of insulation affects the wire's ability to withstand heat, moisture, and chemicals. PVC is a common and cost-effective insulation material, while FEP offers superior resistance to high temperatures and corrosive substances. The temperature rating indicates the maximum temperature at which the wire can safely operate. Exceeding this temperature can damage the insulation and lead to electrical hazards. The voltage rating specifies the maximum voltage that the wire can handle. Using a wire with a voltage rating lower than the circuit voltage can result in insulation breakdown and electrical shock. The stranded versus solid construction affects the wire's flexibility and ease of installation. Stranded wire is more flexible and easier to bend, making it suitable for applications where the wire needs to be routed through tight spaces. Solid wire is less flexible but may be more durable in certain applications. When selecting wire, it's crucial to consider the specific requirements of the application, including the voltage, current, temperature, and environmental conditions. Using the wrong type of wire can compromise the safety and reliability of the electrical system. The National Electrical Code, NEC, provides guidelines for the safe installation of electrical wiring and equipment. While the NEC is primarily intended for residential and commercial buildings, its principles can also be applied to industrial installations. Some key NEC requirements related to wire selection include ampacity, which is the maximum current carrying capacity of the wire, insulation type, grounding, and overcurrent protection. Ampacity is determined by the size and type of the wire, as well as the ambient temperature and the number of conductors in a raceway or cable. It's essential to choose a wire with an ampacity that is sufficient for the circuit's load. The insulation type must be suitable for the operating temperature and environmental conditions. The NEC specifies different insulation types for various applications, such as dry, wet, and hazardous locations. Grounding is a critical safety measure that helps to prevent electrical shock. The NEC requires all electrical systems to be properly grounded, and the grounding conductor must be sized according to the size of the circuit conductors. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect the wiring from overloads and short circuits. The NEC requires overcurrent protection devices to be sized appropriately for the ampacity of the wire. In industrial applications, wire selection may also be influenced by factors such as vibration, chemical exposure, and mechanical stress. It's important to choose wire that is specifically designed to withstand these conditions. For example, tray cable (TC) is commonly used in industrial applications because it is resistant to oil, chemicals, and abrasion. Another consideration in industrial applications is the use of shielded cable. Shielded cable helps to reduce electromagnetic interference, or EMI, which can disrupt sensitive electronic equipment. Shielded cable is typically used in control circuits and instrumentation systems. When working with electrical wiring, it's essential to follow safe work practices. Always de-energize the circuit before working on it, and use appropriate personal protective equipment (PPE), such as gloves and safety glasses. Never work on live electrical circuits unless you are properly trained and authorized to do so. Electrical work can be dangerous, and it's important to take all necessary precautions to prevent accidents. When in doubt, consult with a qualified electrician or electrical engineer. They can help you select the right wire for your application and ensure that the electrical system is installed safely and in accordance with all applicable codes and standards. Understanding the differences between THHN and TFFN wire types, along with other wire types, is a fundamental aspect of electrical work. It's a combination of theoretical knowledge, practical experience, and adherence to safety guidelines. Always stay updated with the latest codes and standards, and seek guidance from experienced professionals when needed. Remember that electrical safety is paramount, and proper wire selection and installation are crucial for ensuring the safety and reliability of electrical systems. Considering the specific environment and application is very important. For instance, in a high-temperature environment, TFFN might be preferred due to its high temperature rating, provided the voltage requirements are met. In contrast, for general panel wiring where the voltage is within the 600 volts range and cost is a concern, THHN is a more economical choice. Also, consider the flexibility needed. While TFFN is only available as a solid conductor, THHN offers both solid and stranded options, making it more versatile for different wiring configurations. It's also worth noting that some applications might require specific certifications or listings for the wire used. For example, in some marine applications, marine-grade wire is required, which has specific properties to resist corrosion and withstand a harsh marine environment. Similarly, in hazardous locations, such as those with explosive gases or dust, specially rated wire and cabling must be used to prevent ignition. Always consult with the relevant codes and standards for the specific application to ensure compliance and safety. Furthermore, proper termination and connection techniques are essential for maintaining the integrity of the electrical system. Use appropriate connectors and tools for the wire type and size, and ensure that all connections are tight and secure. Loose or corroded connections can cause overheating, voltage drops, and even electrical fires. Regularly inspect electrical wiring and connections for signs of damage or deterioration, and replace any worn or damaged components promptly. Preventive maintenance is crucial for ensuring the long-term reliability and safety of electrical systems. In conclusion, the choice between THHN and TFFN wire depends on a variety of factors, including voltage, temperature, environmental conditions, and cost. Understanding the differences between these wire types, as well as other wire types, is essential for selecting the right wire for a specific application. Always follow safe work practices and consult with qualified professionals when needed to ensure the safety and reliability of electrical systems. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer for specific recommendations and to ensure compliance with all applicable codes and standards. Remember, Electrical safety is a shared responsibility, and it's up to each individual to take the necessary precautions to prevent accidents and ensure the safety of themselves and others. Choosing the right wire involves considering the load requirements of the circuit. Overloading a wire can lead to overheating and potentially a fire. It is important to calculate the total current that the wire will need to carry and then select a wire with an appropriate ampacity rating. The NEC provides tables that list the ampacity of different wire types and sizes under various conditions. These tables take into account factors such as the insulation type, the ambient temperature, and the number of conductors in a raceway or cable. It is important to consult these tables to ensure that the selected wire has sufficient ampacity for the intended application. In addition to ampacity, it is also important to consider the voltage drop in the wire. Voltage drop occurs when the voltage at the end of a wire is lower than the voltage at the source. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The amount of voltage drop depends on the length of the wire, the current flowing through the wire, and the resistance of the wire. It is important to calculate the voltage drop to ensure that it is within acceptable limits. The NEC provides guidelines for calculating voltage drop and recommends that the voltage drop should not exceed 3% for branch circuits and 5% for feeders. When selecting wire, it is also important to consider the environment in which the wire will be installed. Some environments may be harsh or corrosive, and it is important to select a wire that is suitable for these conditions. For example, in wet locations, it is important to use a wire that is rated for wet locations. In areas where there are chemicals or solvents, it is important to use a wire that is resistant to these substances. Failure to select a wire that is suitable for the environment can lead to premature failure of the wire and potential safety hazards. Another important consideration when selecting wire is the ease of installation. Some wires are easier to install than others, and it is important to select a wire that is appropriate for the skill level of the installer. For example, stranded wire is generally easier to bend and pull than solid wire, making it a better choice for applications where the wire needs to be routed through tight spaces. Additionally, some wires have special coatings or lubricants that make them easier to pull through conduit. Proper wire selection and installation are essential for ensuring the safety and reliability of electrical systems. It is important to follow all applicable codes and standards and to consult with a qualified electrician or electrical engineer when needed. Remember that electrical work can be dangerous, and it is important to take all necessary precautions to prevent accidents. In the context of industrial applications, it's critical to consider the specific machinery and equipment being powered. Some equipment may have specific wire type requirements or recommendations to ensure optimal performance and longevity. For example, sensitive electronic equipment may require shielded wire to minimize interference, while high current equipment may necessitate larger gauge wires to handle the load safely. Furthermore, industrial environments often involve exposure to various chemicals, oils, and other substances that can degrade wire insulation over time. Selecting wires with appropriate chemical resistance ratings is essential to prevent premature failure and maintain a safe operating environment. In addition to chemical resistance, mechanical protection is also a key consideration in industrial settings. Wires may be subjected to abrasion, impact, and other physical stresses, so it's important to choose wires with durable jackets and appropriate mechanical protection features. For example, using conduit or cable trays can help protect wires from physical damage and extend their lifespan. Another aspect to consider is the potential for vibration in industrial environments. Vibration can cause wires to loosen or break at connection points, leading to equipment malfunctions or safety hazards. Using vibration-resistant connectors and securing wires properly can help mitigate these risks. Regular inspection and maintenance of wiring systems are crucial in industrial settings to identify and address potential problems before they escalate. This includes checking for loose connections, damaged insulation, and signs of corrosion or wear. Implementing a preventive maintenance program can help extend the lifespan of wiring systems and minimize downtime. Furthermore, proper labeling and documentation of wiring systems are essential for troubleshooting and maintenance purposes. Clear and accurate labeling can help technicians quickly identify circuits and components, reducing the time required for repairs and modifications. Maintaining up-to-date wiring diagrams and schematics is also crucial for effective troubleshooting and maintenance. In conclusion, wire selection for industrial applications requires careful consideration of a variety of factors, including electrical load, environmental conditions, mechanical stresses, and vibration. Consulting with qualified electrical engineers and following industry best practices can help ensure the safety, reliability, and longevity of wiring systems in industrial environments. Remember that electrical safety is paramount, and taking the necessary precautions to prevent accidents is essential. Proper wire selection is not just about meeting code requirements, it's about creating a safe and efficient electrical system that will perform reliably for years to come.